Hey guys, today I will be talking about the applications of linear algebra in cryptography. So first, what is cryptography? It's a form of private communication between two parties which involve encoding and decoding secret messages. It's been around for thousands of years. It was created by the Greek, and it's very prominent in our society today. It protects digital currency, computer passwords, and it's used in the military. Speaking of which, I wanted to talk about the Enigma machine really quick. This was an encryption device used by Nazi Germany during World War II, and it was just to protect their military communication. In 1932, Polish cryptologists started working on figuring out the code. They eventually gave their information to the British and the French, and in 1941, British cryptologists finally decrypted the Enigma code. If you've seen The Imitation Game, that movie is all about this. First, I want to talk about some definitions before we get into everything. Plain text is the original secret message. Ciphertext is the unreadable secret message. Encryption is the process of translating plain text into ciphertext, and decryption is the process of translating ciphertext into plain text. So with that, this is just a little overview about what we're going to do. So to encrypt our message, we will be using an encoding matrix and use matrix multiplication. And we multiply the encoding matrix by the plaintext matrix. This will result in a ciphertext matrix, and we will linearize this into an unintelligible message using code. And then to decrypt this message, we will use matrix multiplication once more. We will instead use a decoding matrix, which is just the inverse of the encoding matrix, and we'll multiply that by the ciphertext matrix, which will give us the plaintext matrix, which will then be linearized into the original secret message. So to start off with the encryption, we'll need our encoding matrix, which will also, it has to be invertible, and this will give us the decoding matrix, and we'll also need to define a key. It can be anything you like. I chose the alphabet and a little underscore for my space. So now to encrypt our message, we need to start with our plaintext message. I chose Elvis is in the building because I thought it was, or Elvis has left the building because I thought it was like a spy message, I guess. And you can see that I used the key and assigned each letter its numerical value. So now we want to take all of those numbers and we want to put them in 3x1 vectors. We put them in 3x1 vectors because our encoding and decoding matrices are 3x3. If these were 2x2 matrices, we'd then do 2x1 vectors. And these will give us our p vectors. Now to encrypt the numerical plaintext, each p vector will be multiplied by the encoding matrix. This will then give us the matrix B, and these are the elements in the ciphertext. So below is just the math doing that. And you can see our matrix B. And now we take matrix B and divide it into 3x1 vectors we'll call B. And then once again, we'll take the numerical values and linearly sort them. And we get this sequence of ciphertext. And as you can see, some numbers are negative, some are greater than what the key allows. And this means we'll have to use modular arithmetic. Modular arithmetic is a system in which once numbers reach a certain value, they'll wrap around to the beginning. For our purposes, I'm not going to go too much into it. But here I have the modular arithmetic below. And then I assigned each number to the key. So with that, it gave us this encrypted message that doesn't make any sense. So if a third party were to intercept it, they wouldn't know what it meant unless they had the key and the decoding matrix. Now let's decrypt this message. So you'd receive the ciphertext, and once again you use the key and assign each letter or symbol to its numerical value. And then you put the ciphertext in 3x1 vectors, and these will be our V vectors. And to decrypt the B vectors, they will get multiplied by the decoding matrix. And this is the inverse of the encoding matrix. And if you look at how B was found, we multiplied the encoding matrix by our P vectors. And now we are multiplying our B matrix by the decoding or inverse. So when we do that, we end up canceling the matrices, the encoding and decoding matrices on the right side, and we will end up with our P matrix back. And this is just the math involving that. And below is our P matrix. So the matrix P will be divided into 3 by 1 P vectors. And once again, these values will be linearly sorted. And below you can see that these numbers are really, really big. Once again, they don't fit into the key. So we will use modular arithmetic. And this is the sequence after modular arithmetic has been applied. Now, once again, we use the key and we coordinate each number with the letter. And then our secret message has been decrypted and it reads, Elvis has left the building. So that was my presentation and I hope you guys enjoyed.